Gates and runners. 1. All tools are to be designed so the parts are automatically degated. Tool shops must receive written permission from the Amer program manager if a tool is to deviate from this requirement. 2. Runner systems are to be designed to reduce pressure drops and provide adequate flow from the drop to the individual gates. 3. The gate location should be in an area free of obstacles like core steel with thin steel conditions. Any area that can be affected by thermal expansion and deflection. 4. All tools with more than one cavity must have a runner shut off for each cavity. Each runner shut off must be able to be modified from the parting line face without removing the tool from the press. 5. Runner systems should have a cold slug at each branch point. The gate should not be located at the end of a runner. All cold slugs and runner ends should be vented. 6. Part cavitations should be balanced by using the appropriate gate sizes instead of choking off the runner. 7. Tools that mold around in mold film appliques are to utilize tab gates and shall be fed by a tunnel gate. Tab gates will be formed and ejected by a rectangular ejector pin which is larger than the thickness and width of the tab. The thickness of the tab should be equal to, or greater than the nominal wall stock and should be choked down at the intersection of the part to an acceptable thickness. The taper on the gate tab must allow for easy removal by the robot. The size of the tunnel gate must be large enough so that it does not freeze before the gate from the tab to the part freezes. 7. Ejector pins located under a pin gate, as well as the gate itself, are to be surrounded by a stationary ejector sleeve insert. 8. Sucker pin undercuts should be located in the side walls of the runner, below the drop, not in the runner slug. The ejector pin under the hot drop should have a stationary ejector sleeve insert around it and around the runner slug. 9. All gates should be designed to ensure that a proper gate freeze is possible after the part is adequately filled and packed out. 10. All tunnel and cashew gates should have a lead-in horn or root which is larger than the gate size. This is to allow for easier gate tuning or resizing. The entire gate feature does not have to be modified. 11. Cashew gates can be designed with either a vertically split insert or a horizontal split, cap type, insert. If the cap insert style is used, then all of the cashew features are to be located in the cap insert, for ease of adjustment. 12. It is preferred to have cashew inserts which are removable from the parting line face without having to remove the tool from the press. 13. Cashew and tunnel gates should have as slender a side profile as possible in order to allow for easier material flexing when they are ejected from the molding steel. If material flow is a concern, then the width of the entire gate feature should be increased. 14. Cashew and tunnel gates are to be designed in a manner that minimizes the possibility of cosmetic molding flaws such as jetting, blush, splay, halos, etc. 15. All tunnel and cashew gates are to be polished and free of any sharp edges, flash, EDM scale, cutter marks, burrs, etc. 16. A plan view, isometric view, and a section view cut through each gate must be submitted to the Amer program manager for approval before steel is cut. 17. Applique tools that have wrapped parting line edges should have gates located so that the material fills this edge first and then flows away from it. This is to allow gas to escape through the vented edges, which are not wrapped by the applique. 18. Tools running TPE, TPU, or TPV which have cold sprues feeding parting line runners, should have gusset ribs cut into the sprue bushing to strengthen the joint between the runner and the sprue. 19. Whenever possible, runners that feed gates should have a minimum of 2 ejector pins in order to provide balanced ejection of the runner and gate. 20. If a tunnel gate or cashew gate is feeding into a part feature which is almost parallel to die draw, then the ejector pins under the runner need to have a delay which is slightly greater than the size of the gate in the cut shear direction. 21. All ejector pins which are located under runners must be locked to prevent rotation. 22. All runners with a tunnel gate or cashew gate must have a runner flex notch incorporated near each gate location in order to facilitate the ejection of the trapped gate from the tool steel and to reduce the snapback. The design and location of each flex notch will be reviewed at the design review stage. 23. All runners to be polished to remove tool marks. 24. Tools running glass-filled resins are to have hardened inserts at gate locations. 25. For two-shot tools, the first shot is on the operator side and the second shot is on the non-operator side. Runner push slugs must be designed with enough depth to properly eject the runner and gates from the molding. Steel. Depth of the slug must be at least equal to the distance from the gate to the push slug. Additional ejector. Pin land should be designed to allow for tuning if required. The push slug and ejector pin should ride through a polished stationary insert. Use an ejector sleeve to reduce resin shaving or flaking. The runner and push slug should have a generous radius at their intersection. Larger diameter push slugs should be cored out to allow proper resin solidification. Independently located tunnel and cashew gates should have either a Z-style sucker pin or a dummy gate of similar style, located on the opposite side of the push slug in order to balance the runner. Forces. The Z-style sucker pin, or equivalent styled anchor, must be designed so that it does not interfere with the robot removal of the runner system. The stationary ejector sleeves must have sufficient ID-bearing surface to form the longest possible runner slug, and provide proper support and seal off to the ejector pin that travels through it. The initial length of the runner push slug should not be more than 12 mm and it should have 0.5 to 1.0 degrees of draft on the OD. This allows a steel-safe condition on both the ejector pin and the stationary sleeve if the runner push slug depth needs to be increased to the maximum amount. These are the design criteria for core out for larger diameter slugs. Thank you for your time. My name is Amer Janineh and please watch my other mold design videos.